Hello everyone! This time we will explore one-sided limits of a function. Please subscribe on my channel.
Answer or review. Number 4, we are going to solve activities activity number 4, part of your assignment. So we have there the given for number 4, the limit, remember the limit of the cube root of h plus 1 minus 1 over h as h approaches to 0. So we are going to solve this one by applying, so remember the perfect cube, a cube minus b cube. When you're going to factor this one, we have form a binomial, a minus b, then form a trinomial, a squared, you square the first term, change the sign, multiply the first and the second, then square the last term. So that is the standard. So this time, same with the perfect cube, since this is a perfect cube, cube root of h plus 1, and 1 also is a perfect cube. So we have here, we're going to copy the given, cube root of h plus 1 minus 1 over h. Okay, we'll just write here as h approaches to 0 first. So multiply by, so this is our a minus b, so multiply by a trinomial. So we're going to form a trinomial. You squared h plus 1 squared, then change the sign, then multiply cube root of h plus 1 times 1, so that is cube root of h, then negative 1 times 1, that is positive 1. So what you're going to multiply in the denominator, same with the in the numerator, same with the denominator. So h plus 1, we have here squared plus the cube root of h plus 1 plus 1. So when you multiply, so this one, or this is the factor now, so you may form, this is now the limit of the cube root of h plus 1 cube, kay perfect cube, minus 1 cube. Since you're going to form this one from this, from the factor, you have there the standard form. Divided by h times the quantity, the cube root of h plus 1 squared plus the cube root of h plus 1 plus 1 as h approaches to 0. Okay, so this one you may cancel, and then remaining here the limits of h plus 1 minus 1 all over h times the cube root of h plus 1 squared plus the cube root of h plus 1 plus 1 as h approaches to 0. So with this one, 0. Then since this is now multiplication, remaining is h, so you may cancel this one. So it's very safe to cancel. And then you may substitute now. So the limits, so 1 over the h is 0, 1 over this, the cube root of 0 plus 1, and of course squared, plus we have there the cube root of 0 plus 1 plus 1. So final answer, 1 over, this is 1, 1, 1. So 1 plus 1 plus 1. So final answer is 1/3. So this is now the answer for number 4. Okay, so we are now in one-sided limits. One-sided limits, if the value of f of x can be made as close as we like to L by taking values of x sufficiently close to a but greater than, then we will write the limit of f of x as x approaches to a from the right. Positive there is the direction, from the right is equal to L. And if the values of f of x can be made close as we like to L by taking values of x sufficiently close to a but less than a, then we'll write the limit of f of x as x approaches to a from the left. So you may take values from the left is equal to L. So the limit of a function f of x as x approaches a from the right is L, or f of x approaches to L as x approaches to a from the right. Similarly, is we have the limit of f of x as x approaches to a from the left. Okay, so we have, you can write like this. So we have here the two-sided limits. The two-sided limits of a function f of x exists at a if and only if both of one-sided limits exist at a and have the same value. That is, the limit of f of x as x approaches to a is equal to L if and only if the limit of f of x as x approaches to a from the left is equal to the limit of f of x as x approaches to a from the right. The two limits from the left and from the right are equal, so which is equal to L. So therefore, the limit exists. So for example, find the one-sided limits if they exist. So we have here the functions in all the three figures have the same one-sided limit. So we have the limits of f of x as x approaches to a from the right is 3. And the limits of f of x as x approaches to a from the left is 1. So the two-sided limit does not exist. Why? They are not equal. Another example, find the two-sided limits and sketch the graph. Here, the g of x is 6 plus x if x is less than -2, and you will use x squared if x is greater or equal to -2. So when you evaluate the limits of g of x as x approaches to -2 from the left, we have there substitute -2, 6 minus 2, we have 4. And the limits of g of x as x approaches to -2 from the right is x squared. So you will use x squared since from the right, so greater than -2, so x squared. -2 squared is 4. So since the limit of g of x as x approaches to -2 from the right is equal to the limit of g of x as x approaches to -2 from the left, then the two-sided limit exists and is equal to 4. So the limit of g of x as x approaches to -2 is equal to 4. Another example, find the two-sided limit if exists and sketch the graph. We have f of x is equal to 3 plus x squared if x is less than -2. 0 if x equals -2, and 11 minus x squared if x is greater than -2. When you evaluate the limits of f of x as x approaches to -2 from the left is limit of 3 plus x squared as x approaches to -2 from the left. So 3 plus -2 squared, we have 7. And the limit of f of x as x approaches to -2 from the right, you are going to write 11 minus x, the limit of 11 minus x, y, from the right of -2, greater than -2, 11 minus x squared. So 11 minus -2 squared, we have 7. Since the limit of f of x as x approaches to -2 from the right is equal to the limit of f of x as x approaches to -2 from the left, then the two-sided limit exists, and this is equal to 7. So the limit of f of x as x approaches to -2 without the sign, it's either left or right, is equal to 7. Okay, this is your activity exercise. You're going to sketch the graph. So you are going to review, use your calculus 1, how you're going to sketch the given function. Why? You sketch the graph in a graphing paper of the following functions and the indicated limits. Find the indicated limits if it exists. Number 1, we have only 2 numbers here. Sorry for the wrong. This must be 1 and the number 2. Find the limits of the given function, the two-sided limit if it exists. So f of x is equal to x squared if x is less than or equal to 2. And 8 minus 2x if x is greater than 2. Second, f of t, that is equal to t plus 4 if t is less than or equal to -4. And 4 minus t if we have -4 is less than t, or t is greater than -4. Okay, this is all for now. Thank you for listening. You can comment if you have questions.
Thank you for watching. Please check my other mathematics tutorials. Don't forget to subscribe on my channel. It's free.